Okay, good day everyone. Yeah, good day everyone. So today we're going to be solving some questions on motion. Yes, some jam questions on motion. The first question I'm going to be solving today is based on differentiation, right? So when you differentiate an equation, right, an x equation, you are differentiating it to the velocity. Right, when you differentiate the velocity, you're differentiating it to the acceleration. So let me bring in a question. So this question is not always asked in Jamb, but it can be asked in Jamb. So take note. This question is not always asked in Jamb, but it can be asked in Jamb. So it's just a slight differentiation, just a very easy differentiation. So this thing, they said the distance x meters traveled by a particle in time t seconds is described by the equation x is equals to 10 plus 12 t square. So find the average speed of the particle between the time interval t is equals to 2 seconds and t is equals to 5 seconds. Between the time interval, take note. So first and foremost, like I said, is a slight differentiation, right? You have something like this when you are differentiating, right? If you have x and raised to the power of, let's say x, let's say raised to the power of x, right? Or let's say raised to the power of 2. Yes, if you have this, and when you are differentiating this kind of equation, right, it will be equals to 2 times x n, 2 times x n raised to the power of 2 minus raised to the power of 2 minus 1, 2 minus 1, right? So this will be equals to 2x n raised to the power of 1, right? So which can also be written as 2x n. So this is a very correct description of general differentiation. Yeah, it's a general differentiation formula. So take note of this. Very important. Very important. So take note of it. It's very important. So um so let's go to the main equation. Let's go to the main equation. So we have 10x. We have x equals to 10 plus 12 t squared. Note when you're differentiating a whole number, right? When you're differentiating a whole number is equals to 0. That is when you're differentiating 10 is equals to 0. So let's differentiate 12t raised to the power of 2. So let's differentiate 12t raised to the power of 2. So if we have 12t raised to the power of 2, it should be equals to 2 times which is the power times 12 t raised to the power of 2, then you minus that same power minus 1, right? So we'll be left with 24 t raised to the power of 1, which is the same thing as 24 t, which is the same thing as 24 t. So take note of this. Very important. So we just differentiated 12x, right? We differentiated this to 12t raised to the power of 2. So we are left with, so our x, right? Our x right now will be equals to 24t. Take note, our x will be equals to 24t. So take note of this. So our x will be equals to 24t. So this is the first step. If we have our x as 24t, right? If we have our x as 24t. So remember, they say at the time interval of 2 seconds and 5 seconds. So we are going to place 2 seconds inside this 24t, right? So let's do that. So our t now, our t, which is the time interval, is equals to 2. When our t is equals to 2, let's write it as this. When t is equals to 2, we have x is equals to 24t. So x will be equals to 24 times 2, right? So which is equals to 48. So let's take the 48 down, which is equals to 48. So take note, that's the first one, right? This is the first one, equals to what? 24. So let's do this for 5 seconds too, because they say at the time interval. So we'll do it for 5 seconds too. We let's say when t is equals to 5, when t is equals to 5 seconds, our x is equals to 24c, right? So 24 times 5 should give you what? You can just go to your calculator. 24 times 5 give you 120. So that's good to go. We have 120. So okay, we have this as 120, right? So now you should know we're talking about the time interval. So if we're talking about the time interval, that means it will be the second time minus the first time, right? Because we're talking about the time interval. So it will be the second time minus the first time. And what's the second time? The second time is 5 seconds. Yes, which we had as 120 minus the first one, which is 48. So let's do that. So the time interval. So let's just say the interval, right? So equals to the second x, because we have gotten the first x. Second x minus the first x, right? That means we have 120 minus 48. So we can go straight to our calculator. 120 minus 48 is equals to 72, right? So 72 is very correct. Very, very, very correct. So take notes. That's our correct answer. So take note of that when you are differentiating or when you are asked. So it is very correct. So I believe you understand this using differentiation. So in case you are asked to differentiate, remember the first differentiation you are asked average speed. Average speed is equal to distance over time, right? The difference between speed and velocity is displacement, right? And one is in a specific direction and one does not have direction. That means one is a scalar quantity and one is a what? Vector quantity. But in this case now, average speed means velocity. So that means you are differentiating the function to get the velocity, right? If you get the velocity, they might give you velocity and ask you to find the acceleration. That means you just have to differentiate it again to get the acceleration, because a double differentiation from the function is the acceleration, a single differentiation from the function is the velocity. So take note. I believe you understand this. Okay, let's move to another question in motion. I believe you understand this. We can move to another question in motion. Okay, let me get the question right. So let's look at another question in motion. Another question in motion. think this should be a simple one, right? Yeah, this should be a simple question from motion. Yes, let's read. They say a palm fruit dropped to the ground from the top of a tree 45-meter tall. That means you just give us height, right? 45-meter tall. You just give us the height. So we have a height is 45. And how long does it take to reach the ground? They're asking for the time and they're giving us gravity. So let's put everything together. Remember, you have different type of formula. Let me bring down the formula. You have this formula, right? Equals to u square, right? Plus 2ax, right? You also have this formula in this equation of motion. You have this formula, right? You also have this formula. X is equals to 1 over 2. No, x is equals to ut plus 1 over 2 ac square. So these are some equations of motion formula, right? So I believe we should be used to all these formulas by now. I believe so. We should be used to all these formulas by now. So now we want to find a suitable formula from this, right? So we're giving um our height as 45 and um g, which is gravity, acceleration due to gravity as 10, and that is a constant, right? So let's look for what we asked. Remember, this u was not given, so it will be 0, right? Height was given to 5 meters. Gravity is always there, obviously. 10 meters per second, right? Yeah, 10 meters per second. What else? We asked to find time, right? Asked to find time. So with this equation, we look for a suitable formula. We look at this first formula. I don't think it will be suitable for also use to find time because there's nothing like there's acceleration due to gravity, but there's no height, right? So this formula is not useful for us. Let's check this formula. To look at this formula. Okay. This formula. Okay. This formula I don't think it's also useful to us. It's not useful to us because there's no time. So let's look at the last formula. Remember S is distance. It can also be written as H, which is height. Remember 1 over 2 UT, right? Okay, yeah, it has what we need. And 1 over 2. Remember acceleration is A. It can also be written as G. Take note. C square. So this formula has everything we need to look for C. So remember, let's put everything into the equation. Our U is 0, right? Yes, our U is 0. So we'll be left with 0 times T, right? Because we have to look for T, which is 0. 0 times T, bracket close, plus 1 over 2. 1 over 2. Our acceleration is given, which is 10. So times 10 times what we're asked to look for, T square, right? Yes, what we're asked to look for, T square. And this, our height is 45, right? Yes. So we have something like this. Our 45. So 45 will now be equals to 45 will now be equals to 0, right? Let's drop this first. Let's drop this first so I don't get too large. Let's drop this first. Right? So we have this first. So our 45. Let's go. Our 45 will be equals to 0. Remember, 0 plus 1 over 2 g, which is 10. Gm2 cancel itself 1 and to cancel 5. To cancel 10 to give 5. So you have 5 times 6 square, right? Yes, 6 square. So with this now, we can have 45 equals to 5t square, right? So our 6 square is equals to 45 divided by 5. 45 divided by 5, we should know that it's 9, right? So we have 6 square equals to 9. So to us to find t, we have to square both sides. We have to square root both sides, right? So square root this side, c square equals to 9 square root of 9, right? So we're left with t, which is equals to, because square will cancel the square root, which is equals to 3, right? So this is very correct. This is our correct answer. So take note. It's very, very correct. Very, very correct. So take note of this. Very, very, very correct. So this is our answer. Our answer is 3. So using this equation, right, we got this answer. So take note of that. Okay, so let's take another question. Yes, let's take the last question for the motion 7. There are much questions on motion. There are as many as possible. It's left for you as a Jamb candidate to solve as much as possible questions. So let's take another question. I believe you understand that. So let's take another question. Let's take one question from motion. Okay, let's take looking for let's take this question. Okay, say a man starts from his home with a speed of 45 kilometer per hour on a straight distance on a straight road. His office 40. Okay, they have given us his distance, right? 45 meters away from home. So first of all, we need to find um the distance, right? So we have, remember, he goes to work and he comes back, right? No, just go to work. That means he goes to work and he come back, right? So the distance using the speed 45 kilometer per hour is 4 kilometer per hour, right? Because distance, remember, distance is speed times time. That 4 kilometer per hour. Let's check it. So 4 kilometer per hour times, what's distance? Distance is speed times time times speed times time, right? So times remember we are using speed times time, so times this. So we'll be left with 4 kilometer, right, as the distance. So remember he went going and coming. So the distance now, which is x is represented as distance, will be equals to 4 plus 4, right? 4 plus 4, which is equals to 8, which is equals to 8. Take note. So we have gotten the distance, which is equals to 8. So take note of this one, right? So if we have gotten the distance as this, so we want to get this yeah, we want to get the speed. It's we want to get the speed he used, right? Because you're asking then the path length covered is, so now they're asking of the total distance, right? So this should be for the time, not for the distance. If they're asking about the total distance, then this is the time, right? So if this is the time, let's edit it. If this is the time, that means we are going to be looking for the time, right? So we have it as 8 hours, right? Total time, we have it as 8 hours, right? Yes, so we have it as 8 hours. So that should be the time, not the distance, if you are looking for the total distance. So if we have that, then we are going to be calculating for um the speed, right? Take notes. We already have um on a straight road to his office 5 kilometers away from home. That's the distance, right? 5 kilometers from home. That's the distance. So now we are going to be looking for the time. Oh, okay. Now I see the mistake. So this is actually the distance, not the time. So take notes. As a mistake, this is actually the distance, not the time. So we were correct the first time. So now we're going to be looking for the time, right? So looking for the time is um is our distance over the speed. So our distance is 5 over the speed, which is 4, plus 5 again over the speed, which is 4. So 5 divided by 4, we can go to a calculator. 5 divided by 4, 1.5, 1.5 plus 1.5 plus 1.5. So we have 2.5. So our time now, our time is equals to 2.5 hours. So take notes. Right, I believe we're following. When you're writing your jam, you don't have to solve it this slow, because I'm teaching. That's why I'm solving it this slow. So we have our time as this. So our total distance now, right? The total distance covered is remember, distance is speed times time, right? So our total distance covered is 8 times 24. So 8 times 2, 2.5, right? So our total distance covered is 8. We can just go through 8, which is the speed, right, times the 2.5, which is the time, right? So you can just write it down if you want to. So I'm the one teaching, so 8.2.5, which is equals to 20, right? So if this is equals to 20, and they're asking for the part covered, the part covered, then the part length covered is, okay, now they're asking of 1. So if I've gotten it as 20, so 20 divided by 2, right? 20 divided by 2, 20 divided by 2, 20 divided by 2 is 10. Right? So our answer is 10. Take notes. Answer is 10. Answer is 10. So this is very correct answer. So take note. So this is supposed to be our speed, not our distance. Our speed. So this is speed. This is the speed, not our distance. So it's actually supposed to be plus itself, which is 4 kilometer per hour. Take note. Sorry for the mistakes. Right. So our distance now is the 8 we have gotten times the 2.5, which is 20. And since they're asking for only one part, so 20 divided by 2 is um 10 kilometer. So which is the um distance covered in one part. Right. So but the distance covered in two places. Right. So the answer is 10 kilometers. So take note. I hope we understand this. So let's just take one more question. One more question. One more question. Okay, let's take this question. Let's take this question. Okay, so we have a bus decelerating. What does deceleration mean? That means reducing. So deceleration is minus. That means we have our acceleration as minus 4. Take note. So acceleration as minus 4 meters per second square. So change with the speed of 60. Speed, it can be also seen as velocity, right? It can also be seen as velocity. And the final speed is to a certain level. Okay, so because it literally have direction, it can be seen as velocity. So to a certain level, to a certain value in 5 seconds. So our time is 5 seconds. So the final speed, and we're looking for v. Right, this is a very simple question because we have our acceleration a as minus 4 because it is decelerating, and u because it has direction as 60. Let's check if it's 60. Let's copy this first. I think that's 60. Yeah, 60. And our time at 5 seconds. And our time, forget that I'm not putting the units. When you're always solving, make sure you put the units as 5 seconds. So the equation of motion for this is very simple. Since we have to look for v, we already have this equation in our head as u plus ac, right? So yeah, we use this equation. U is 60. A is -4 times 5. So we can actually put bracket here, right? So yeah, we have it to be 60 plus -20, right? Yeah. So minus and plus means we have minus. So it's 60 minus 20 is equals to 40 meter per second. Yeah, this should be our answer. Without stress. Yeah. So our answer is 40 meter per second, which is A. So I believe we understand this. So this is where we're going to be stopping for today in some questions under motion. I hope you had a great time. See you next time. I remain from wisdom. Thank you.